So we had the refractory base for the forge floor poured. I didn't have quite enough to do the entire frame as well as do the burner that we're going to be getting to next. So what I'm doing for now, I put a layer of K-wool in here, so there's 2 inches of K-wool. We're going to go over it with a green patch for now, just to give some protection. And then I've got to order more, obviously more refractory cement. So some very important things here when you're dealing with a refractory cement. Now I know I glossed over the mixing and the pouring because it's kind of redundant. It's no different than doing any other kind of concrete, except for your moisture content is extremely important. Your refractory cements aren't going to be a soupy mess. It's not going to be, you're going to look at it and you're going to think, boy, that's awful dry. That's normal. When you actually pour that stuff and you get it all poured, you could actually see the water come to the surface, then it looks like a lot more than what it is. What you have to be careful with this stuff is if you get too much water in it, you're subjecting the floor of this forge to some crazy temperatures. You're going to be hitting this upwards of 2,000 degrees or better depending on what you're doing with it. Now, a lot of forging temperatures aren't quite that high, but they're really substantially high. If you have, I mean, everybody knows water boils at 212 degrees or something like that. You have water trapped in this refractory cement, it's going to create a little bomb for you, worst case scenario. Worst case scenario, you're going to be forging along, heating this thing, and you're going to get a big pow and you're going to have stuff fly all over the place. I'm not talking like take a building out, but I'm saying chunks of refractory probably blowing out of this thing. You could get hit with it, whatever. That's worst case scenario. Best case scenario, if you did not dry or cure this properly, it's going to crumble apart inside and then it'll be kind of useless to you. And that stuff's expensive. I mean, refractory cement is very expensive. I want to say I spent over $100 on that 30-pound bag and to get what we needed for this. This is not your Rutland refractory cement that's only good for like 2,000 degrees or lower, I believe. Very important. The other thing we did is we used our green patch, which is good up to 3,200 degrees, and we put several thin layers, keyword thin layers, over top of this K-wool to form the roof and the walls of our forge. The base of this forge is what I really want solid. If I were to use this stuff for the forge floor just on top of the K-wool, it wouldn't last very long because the K-wool being soft, the weight of your pieces are going to press down, it's going to break it up, it's going to be a pain in the ass. You'll have to constantly be redoing it. Plus, you start breaking that K-wool up, you're going to start getting fibers in the air, and they're so minute, they're so tiny, they're nasty stuff to deal with. That's why respirator, use the rigidizer, anything to keep those fibers down. It's the same as if you're dealing with asbestos. You wet it down before you touch it. Same concept. So what we did is we put rigidizer over everything that's exposed. This will not be exposed much longer. We have to cut a piece of steel, a piece of 1/4-inch plate. We're going to make for the front of our forge, and then we're going to do another layer of K-wool inside to match it, and then we're going to do, finish up the end with the green patch and all that. We are going to be putting a small door, smaller than a fire brick size, on the back of this, and that's just for longer, thinner pieces. But for the work that I do, we're looking at axes and hatchets and things like that. I'll be able to fit quite a bit in here. So you notice too that I've got a piece of K-wool on the front here. This isn't permanent. I didn't have enough refractory to do the entire forge floor, this whole frame, as well as do the burner. It took more than I thought it was going to take. This is a 1-inch thick floor on this thing, or a little bit over an inch, 1.25 maybe. So 30 pounds wasn't quite enough. It's 28.5 by 22 or something like that. Maybe not that wide, but it's wide enough. So keep that in mind if you're building one. We're going to have this, we're going to attach this so we can remove it and replace this liner as needed, which will happen probably every year or two, depending on how much we're going to use it. So what we have left to do on this is we have to cast our ribbon burner. We have to do all the gas work. We've got quite a bit left to do. So remember, the important takeaways here, and I know we're rambling on a long time, and some of you don't like that, but that's just the way it is. Cure this stuff properly. This stuff wants 48 hours in room temperature to get the moisture out. That is so important. This has been in for 24 hours, and what I've been doing, I've been speeding the process up a little bit with a heat gun. Let the heat gun blast in here half an hour, turn it off, let it relax. We're not getting it so hot that we're actually generating steam within this refractory. That's where the danger lies. You get steam, stuff pops apart, loud pow. When we're all done with this, we're going to do a whole layer of that green patch over this entire forge floor, because that green patch is an excellent refractory. It'll bounce the heat back. With a forge like this running gas, you need that reflection of the heat bounce back into the forge to actually make it work, because we need to be able to forge weld with this. So anyway, we're going to get our front plate made, all that good stuff. We're not going super fancy on this. This is a pretty simple forge. There's some beautiful ones out there, and I recommend you guys look them up if you're looking to build this. There's some awesome ones. But anyway, we are going to continue on. All right, need to put the mask on. So we're working on casting our base, the new forge. So this is Gertech Firecast refractory concrete. This stuff is rated up to 3,110 degrees Fahrenheit. This is a 30-pound bag. And according to the directions, and make sure you read your specific manufacturing directions because they are all different. And if you don't follow them, you're going to have issues. So, if we're pouring the brickwork lining layer into forms. So this looks like 4 to 4.2 fluid ounces of water to 2.2 pounds of dry concrete mix. Good enough. So I've got my refrigeration scale here, don't tell my boss. We got it zeroed out so we don't have to worry about the bucket weight. If I can even get into the damn package, we'll be alright. There we go. Jeez. I don't think they want me into this. There it is. Now let's see if we can get this stuff all over the place. Alright, so we're looking for 2.2 pounds to start. Whoa! A little bit over. After this batch, we will put our dust mask or our respirator on for this stuff. Probably shouldn't be sucking it up, but hard to talk and explain what I'm doing with this stuff. So we're looking for 4 ounces. That cup, we're going to go a little bit over. And I guess all we do from here is mix it. I do know if you get too much water in this stuff, it's really not good for the curing. I am looking for a specific consistency. Not too bad. It's a little it's not as loose as I'd like to see it. So you guys get where I'm going with this. So I'm going to get mixing a bunch of this. I'm not going to bother running the camera for all of it, but you guys can see what we're doing. Well, now that I made a huge mess in here, not that it wasn't already a mess, but we just made it worse. We've got our front plate mounted, as you can tell, all the refractories in there and done. We're running the heat gun on this. I'm gonna let this probably run, just because it's so cold out here. It's like 9 o'clock right now. I'm probably gonna come out about 1, 2 in the morning and shut it off. So I've got the back opening sealed up with a couple of brick fragments. Got this sealed up a little bit. You have to allow for some to escape, so it's not like we're sealed up tight. The moisture has to be able to leave it, so you don't want a too humid environment to get this stuff to set up. So what I'm hoping, I wanted to get to actually building the burner part itself today, but I don't think that's going to happen. It's getting late and this took a little bit longer than I predicted. I hate welding steel that's super thin. Not that this stuff's super thin, but I have what I have. And stick welder, I can do it, it's just a pain in the ass, it takes a little time. So anyway, next time out we're going to be working on the burner for this. What sucks is once I cast that burner, it has to set for 48 hours. So it's going to be kind of tough to leave the project alone for a couple of days while it does that. But that'll give this more time to set up, get the moisture out of it. We can keep cycling the heat gun and hopefully we'll see what happens. But so, what do we have left? Burner, we got to secure this. I've got refractory mortar around the bottom now on the inside, so it's sealed up really well. We're going to hit it better on the outside as well. It's not going to look pretty. You guys want to see pretty? There's a lot of builds that are very pretty, but I care more about functional than I care about pretty at this point when it comes to stuff like this. It's in a blacksmith shop. It's going to get beat to hell. You're going to have heat marks. It's not going to stay pretty for very long. The other thing, if you're making one of these, I wanted thicker steel for the end where these openings are, simply because there's so much heat in that forge, it's going to burn this metal up over time. So I want that thicker metal, and I like to carry that refractory out as far as I can. I coat the metal itself on the outside around the rim, hopefully to try to help spare it a little bit, make it last a little bit longer. So the forge itself isn't huge, but it's actually a pretty good sized chamber for a gas forge. The ribbon burner is going to be 8 inches long. We're going to have a 2-inch pipe on it. I'll get into that in depth on the next one, because that one's actually going to take some explaining and the whole process behind it and all that good stuff. So thanks for watching, everybody. I hope you enjoyed it, and I'll see you on the next segment.